All right, let's get into 4.6, graphs of other trig functions. So in 4.5, we graphed sine and cosine. And so in 4.6, we're going to graph the rest of them, cosecant and secant, as well as cotangent and tangent. And so tangent is what we're going to start with. So here is the graph of tangent with some points on it. I want to start explaining this by looking back at our unit circle. And let's get our 4 cardinal points. That's not the greatest circle in the world, but that's what we're working with for now. So we've got 1, 0. Up here we've got 0, 1, and we can work all the way around. We've got -1, 0 over here, and down here we would have 0, -1. And then another additional, so for sine and cosine we just use those points as kind of our starting important points. There's another really important one for tangent, and that's the 45-degree angle, the pi over 4 spot, 45 degrees, because that's where we get x and y the same. And so for tangent, when we divide, that's going to turn into 1 for tangent, because root 2 over root 2 is 1. So let's take a look at what we would get if we did a t-table here, right? If our theta starts out at 0 degrees, we're going to have 0 divided by 1 for tangent, right? Using this point here, 0 divided by 1 would be 0, okay? What if we went up to this point here? So if we were at pi over 2, then we have 1 divided by 0, and that's undefined, right? Can't do that. At root 2 over root 2, sorry, at pi over 4, that's the other important point we've added on here, this one here. That's going to be 1. And then we're going to go backwards also. We're going to say negative pi over 4, which is right down here. Negative pi over 4, we're going to get -1, right? And at negative pi over 2, we're down here, we're going to have undefined tangent, because it's going to be -1 divided by 0. So what we have here is we're undefined at negative pi over 2 and pi over 2. We're 0 at 0. And then here's our other important points, right? So in sine and cosine we had 5 important points. We still have 5 important points, just 2 of them are asymptotes here, right? So we have 1 and -1, and these would be pi over 4 and negative pi over 4. So a little bit of a difference here. You'll notice now that from start to finish is not a full circle, right? From undefined to undefined, we're only using a half circle. So the period is just pi, not 2 pi for tangent. All right, so we're going to use that coming in. All right, oh, one other thing to look at. Just look at the graph. It starts low and finishes high. Just something to remember if you're trying to memorize the parent functions here. So let's graph this. Y is tan of x over 2. All right, so the only thing that's changing here is our period. Same thing as before. It's the period divided by b. But our period here is not 2 pi. It's just pi, because we're in tangent. So it's pi over b is going to be 1/2. So pi times 2, or 2 pi, is going to be our graph. All right? So normally we would have an asymptote. Let me flip back to the parent so you can see it. At pi over 2. So now our asymptote is going to be at pi. It's doubled. Normally we would have an asymptote at negative pi over 2, but it's timesed by 2, so we would have negative pi be our asymptote. All right? We're not shifted at all, so we still have 0, 0. We go up to 1 with a dot. We go down to -1, dot here, and these points would be negative pi over 2 and pi over 2. We're going to start low and finish high. Right? Lost my pointer. There we go. And so we have an arrow going up. If we wanted to do another period here, we could go 2 pi, 3 pi, so our asymptote would be on 3 pi now. And we would go like this. And so these points would be 3 pi over 2 and 5 pi over 2. All right? So use the parent function. See if you can graph 1/3 of tan x. 2 full periods. All right, let's talk about this graph of -3 tan of 2x. So I've got an amplitude, and I've also got a period change. So the amplitude is -3. My period is pi over b, which is 2. All right, so if I go to graph this, I'm going to have, normally my asymptotes would be at pi over 2. Now that's cut in half. It's going to be at pi over 4, because it's half as much for my normal period. Here's going to be -pi over 4. So the period between these two things is pi over 2. From -1/4 to +1/4 is 1/2. All right? All right, so normally we'd have there. Now normally we would hit 1 and -1, but now we're going to hit 3 and -3, and we're flipped over. So we're going to start high and finish low this time. So graph looking like that. These points would be -pi over 8 and pi over 8. All right, and so we've got a reflection, we've got a stretch, and we've got a change in our period. See if you can work with the same type of information on 17. Okay, so now let's look at cotangent. Cotangent is the reciprocal of tangent. So when we're looking at that, if this is our tangent graph, and we've got important points here and here and here, right? The flip of that, this is like saying, an asymptote is like saying 1 over 0. So if you flip that over, you're going to get 0. So you'll notice that this was pi over 2. At pi over 2, instead of an asymptote, sorry, -pi over 2, now we have a 0. At 0, if we flipped 0 over, we would be undefined. So at 0 here, can't see it because it's on the y-axis, but we've got an asymptote. If we took a point that was below the x-axis and flipped it over, now we'd be up here. So that's this point that used to be down for -pi over 4, and when we flip it over, where do we go? Now we're going to be here. Sorry, matches up with 1, and now we're going to be here. Matches up with -1. So it's going to start high, finish low. Zeros turn into asymptotes. Asymptotes turn into 0. Okay. There is this trick as well, the bx minus c. Before, remember, it was equals 0 and equals 2 pi. For tangent and cotangent, since the period is pi, we're going to say equal to 0 and equal to pi. So let's see what we can do here. 2 cotangent of x over 3. So we know that we have an asymptote at 0. And normally, flick back, we would have an asymptote at pi. And instead, though, our period is shifted. The period is pi divided by 1/3, which is 3 pi. So normally our period is pi. It got turned into 3 pi. Right? So our stretch is now 3 times as big. We're going to end up way over here at 3 pi for our new asymptote, which means that our middle is going to be 3 pi over 2. And so that's where our dot would be in the middle. And then halfway in between that would be 3 pi over 4. Okay? And then we're going to have, we're counting by 3 pi's over 4. 3 pi over 4, 6 pi over 4, 9 pi over 4. 3 pi is 12 pi over 4. And our amplitude is 2. And we're going to start high, finish low for cotangent. Same as negative tangent, it's flipped over. All right, so 5 important points for 27. See if you can do it. All right, so now let's take a look at the last two, cosecant and secant. And since they're the reciprocals of sine and cosine, what you can do is you can do a little sketch. If we're doing cosecant, we can do a light little sketch of sine, And then you'll notice that the graph of cosecant is the graph of sine flipped over. So here we have a nice little half circle. We've got that circle flipped over. It goes to 0. The flip of 0 is undefined, which means it'll go down forever, right? So we have asymptotes instead of zeros. All right? Period is 2 pi again. We're back to 2 pi. So just tangent and cotangent have periods of pi. So let's see if we can put this all together here. Cosecant, 2 cosecant of x plus pi over 4. All right. To make this simpler, I'm going to think about this as 2 sine x. There we go. X plus pi over 4. All right, because cosecant is the flip of sine. If I were to graph this, I've got everything shifted by pi over 4. I'm going to use the bx plus c equals 0 and bx plus c equals 2 pi trick here. So I know that x plus pi over 4 equals 0, so x equals negative pi over 4, and x plus pi over 4 equals 2 pi over 4, which is 8 pi over 4. So now x equals 7 pi over 4. So those are my starting and ending points here. So negative pi over 4, and then we're going to have 5 tick marks. This is going to be 7 pi over 4. Halfway between pi over 4, negative, and 7 pi over 4, that's a distance of 6. So halfway between that is, it's a distance of 8. Halfway between that is 4. 4 less is 3 pi over 4. Okay? And so halfway between that is going to be another 2 pi. So this will be pi over 4 and 5 pi over 4. You can see the pattern there. And our amplitude is 2 and negative 2. It's sine, so our first dot would be here. We're going to go up. We're going to come back down. We're going to keep going down, and then we're going to finish going up. So if I connected those in the curves, I would have sine. But we're going to flip this over, and we're going to do cosecant instead. So everywhere we see 0, we've got ourselves an asymptote. Any dot that lands at 0 is our asymptote, so the 1, 3, and 5 dots. And then we're going to flip. Normally we'd have a curve coming back down. We're going to flip this over and make it go up. We're going to turn this over and make this one go down. So that's what your curve would look like. That's what your graph would look like for cosecant. So it's starting to get trickier, but see if you can come up with a cosecant graph for 33. All right, last example. We're going to do secant here. Secant of 2x. So I'm going to start by thinking about this as cosine of 2x. And so cosine of 2x, my period is going to be 2 pi over 2, or just pi. No transformations going on. That makes it easier for me. We've got an amplitude of 1 and negative 1. 1, 2, 3, 4. We're going to end at pi. We've got pi over 2. Half of that again is pi over 4, which makes this 3 pi over 4. And cosine would start high, come down, and go back up. But I need to flip that over for secant, so I need to put asymptotes anywhere I would hit 0. We're going to go down instead of up. We're going to go up instead of down. Okay? And so that is our graph of secant. All right, so that's the last one. See if you can make that happen for 2 secant of x plus pi. I know this is getting confusing, so we will definitely go over all of these in class. Okay, just give this a shot. Start thinking about how you would graph secant, cosecant, tangent, and cotangent. Definitely have down all of the parent functions. So this is the last thing here, last slide. Here are all the parent functions. This is in your book. I would definitely have this, okay, in your notes. So good luck with those questions. We'll go over it in class.